Hello, this is Mrs. Scarpel, and in this video I'm going to go over how to evaluate logarithms. Now what you need to remember is that a logarithm is the inverse of an exponential function. So a log base b of x is going to be the inverse of b to the x. Now keep in mind that the inputs and outputs switch places, so the value of x in the exponential function is different than the value of x in the logarithmic function. In the logarithmic function, the 16 would be considered the output of the exponential. So if I want to evaluate log base 2 of 16, I need to think about 2 to what power is going to equal 16. Now, if you don't know these off of the top of your head, you can always take a calculator, and I'm going to pull mine up here, and just test some values. We know that 2 squared is 4, so we don't really need to try that one. Let's just see what 2 cubed is. 2 cubed is 8, not there yet, so let's take 2 to the 4th power, and we end up with 16. So the value of log base 2 of 16 is going to be 4, because 2 to the 4th power equals 16. When we're doing log base 3 of 27, we need to ask ourselves what exponent, what power of 3 will equal the 27. Well, we know 3 squared is 9. 9 times 3 is 27. That means it's going to be 3 to the 3rd power. Log base 4 of 256, again, thinking of it in terms of 4 to what power is going to equal 256. Well, let's take our calculator again and try 4 to the 4th power once and just see what happens. So 4 to the 4th is 256. We got it on the first try there. So 4 to the 4th power is 256. Log base 5 of 625. If I take my calculator again, and let's clear the screen, 5 to the 3rd is 125. 5 to the 5th is 3,125, so hopefully it's 5 to the 4th. 5 to the 4th is 625. So that one is also 4, because 5 to the 4th equals 625. Now you'll notice in these that we have different bases, but we have the same argument. So every logarithm has a base and it has an argument. The base is that subscript, the argument is the value we're finding the logarithmic, completing the function for or evaluating for. So what power of 4 is going to equal 1? Well, we know that 4 to the 1st is 1. We know that 4 to the 2nd is 4. 4 to the 1st is 4, excuse me. 4 to the 2nd is 16. Now, if I go backwards, I would divide by 4, and 4 divided by 4 gets me the 1. If I'm going backwards and I look at the pattern with my exponents, it should be 4 to the 0 power. Let's just verify that using our calculator again. So let's try 4 to the 0. 4 to the 0 power is in fact 1. Well, if 4 to the 0 is 1, does that mean 10 to the 0 is 1? Take that calculator, enter 10 to the 0. It is. How about 9 to the 0? Is 9 to the 0 going to be 1? Pull up that calculator. 9 to the 0 is also 1. So what we can learn from these examples is anytime your argument is 1, your value, excuse me, I wrote 1s when I should have been writing 0s, your value is 0. Because anything, any value to the 0 power is going to be 1. Here we have the base equal to the argument. Well, if we're thinking in terms of what's a power of 8 that's going to equal 8, hopefully you're saying, well, that's 1. 8 to the first equals 8. So that means the value of log base 8 of 8 is going to be 1. If I use that same reasoning on the next one, 3 to what power is going to equal 3? Well, that's 3 to the first power. So that means the value of my logarithm is 1. So anytime your base and your argument are the same, the value of your logarithm is going to be 1. Here we have the base matches the argument, which is taken to a power. Anytime your base and your argument match, the value is going to be the power, the exponent. Now if we think about this, what we're asking is what power of 3 is going to equal 3 squared? Well, in order for these two expressions to be equal, they'd have to have the same value in the exponent. So we can say 3 squared is equal to 3 squared. Therefore, my value of my logarithm is 2. So here we have a base 5, an argument of 5 raised to the 4th power. That's going to be a value of 4. Base 13, argument of 13 raised to a power of 4. That one is also going to have a value of 4. So when your base and your argument match, and you have the argument raised to yet another power, your value for your logarithm is going to be that power. And here, if we think about the base and the arguments, I don't have a power of 3 that equals 11. What I do know is that 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. Well, 11 falls between 9 and 27. So what I can do with this one is estimate that it will be between 2 and 3. Closer to 2 than it would be to 3. And we'd have to be doing a lot of testing in the calculator, and I'll just show you, but for purposes in class, I'm just going to ask that you estimate it like I have here, between the 2 and the 3. So if I clear this and I try 3 to the 2.1 power, because I estimated it would be closer to 2 than it would be to 3. That gets me to 10.045. So if we try 3 to the 2.2 power, that gets me to 11.2. So I could be estimating, okay, it's going to be somewhere between 2.1 and 2.2. So let's try 3 to the 2.15. We're still not quite at that 11. So you can see it's going to take a lot of going back and forth to find that estimate. But again, for our purposes, we're just looking for the exponent that it would fall between. So log base 2 of 21. Well, we know that 2 from earlier in this video, that 2 to the 4th is 16. So if I take 16 times 2, that gives me 2 to the 5th is 32. So the value of log base 2 of 21, because 21 falls between 16 and 32, the value of my logarithm is going to be between 4 and 5. So let's take a look at log base 4 of 50. So 4 squared is 16. If I multiply 16 times 4, that gives me 4 cubed is 64. Because 50 falls between 16 and 64, we can say that the value of this log is between 2 and 3. And this concludes our video on evaluating logarithms.